All right, we're going to take a look at this motion problem. And you can see here that the motion is based on that particular position function. So let's go ahead and answer some of these questions. The position, of course, is just that. So we're just going to plug this in, s of 1, which is 2 times 1 cubed, minus 12 times 1 squared, plus 18 times 1 minus 3. So this is 2 minus 12 plus 18 minus 3. And that's going to be 6 minus 1 is 5. The velocity is going to be the derivative of the position. So compute the velocity by computing the derivative of this. So 2 times 3 is 6, 6t squared. I'm just reading things off of here, up top. So this is going to be going down there. And then negative 12 times 2 is negative 24. And then subtract 1 from that power and it becomes t to the first. And then 18 and t to the 0, which is just 18. And the 3 constant becomes 0. Okay, now we just compute this at 4. So 6 times 4 squared minus 24 times 4 plus 18. Let's see if I can do this. 6 times 16. 24 times 4 is 96. Okay, 6 times 16. Is that 96 as well? It is. So 96 minus 96 plus 18, which is 18. It's the velocity at t equals 4. Now it asks for the acceleration at t equals 3. So the acceleration, you're doing the derivative of the velocity. Velocity derivative. So 6 times 2 is 12. And then 24t to the first, and then we're done. And we want t equals 3, so v prime, or, right, this is a of 3, which is 12 times 3 minus 24, which is equal to 12. Next, when is the object at rest? That is when the velocity is equal to 0. So I want to know when is the velocity equal to 0. So that's going to be 6t squared minus 24t minus, or plus 18. Set that equal to 0. Factor out the 6. That'll make things a lot easier. And then factor that trinomial. And we get 6 times t minus 3, t minus 1. So t equals 3 and t equals 1 are the places where the object is at rest. Okay, speeding up and slowing down. This is confusing because speeding up, this is when the velocity and the acceleration are going the same direction. And acceleration is greater than 0. And slowing, or the velocity is less than 0 and acceleration is less than 0. So that's one way to remember it. And then slowing down is when the velocity and acceleration are going different directions, which we'll get to in a sec. So might help to make a little chart. Let's see. Maybe I'll make the chart like this. Okay, so let's figure out when the acceleration is 0. That'll help. So take this. So acceleration is equal to 0 when 12t minus 24 equals 0. And that gives me t minus, factor out the 12, which is t equals 2. So here's how I'm going to make this chart. I'm going to just pick the range. So the important numbers are t equals 1, t equals 2, and t equals 3. Those are when both, or either, the velocity or the acceleration are changing. So we'll start with the t equals 1, and I'll just say, okay, are we only interested in t greater than 0? Let's just pretend. So between 0 and 1, we'll start with that. Then between 1 and 2, and then from 2 to 3, and then t greater than 3. So those are the ranges, range. And then as far as what we care about is we want to know where these things are speeding up and slowing down. So I need to make some room here. There for my box there. Okay. So let's extend this over. So acceleration or velocity and acceleration. Okay, so essentially what I'm going to do is I'm just going to say, pick a point that's in that range and plug it in to the velocity. So a number between 0 and 1, I'm going to pick a number like 1/2, and I'll plug 1/2 into this velocity here. Let me just box this because that's the answer to this. But I'm going to basically just plug that into this. So if I plugged 1/2 into this function up here for the velocity, the factored version, I would get 6 times 1/2 minus 3, which is a negative number, times 1/2 minus 1, which is also negative. So you have 6 positive 6, times a negative, and positive times negative is positive. So I'm just going to put a plus here. I don't know how positive it is, or, it's fine, just some positive number. Okay, when t is between 1 and 2, we'll do the same thing. Pick a number bigger than 1, less than 2, say 1.5. And when I plug it in here, let's just use, where did that thing go? There, this thing. Okay. That disappears. Very nice. Okay, so we'll plug things in here. So we start with this. That's positive. And then for 1.5 minus 3 is negative. And then 1.5 minus 1 is positive. So you have a positive number, negative, and a negative. So positive times positive times negative times, this was positive. So positive times positive is going to give me a negative number here. If you pick a number like 2.5 and do the same thing, that'll be negative. And then finally 3.5 or 4 or 5, you get positive. So here, just to illustrate this with 5, let's plug 5 into this. This is positive 6, this will be positive 2, and this will be positive 4. Positive times positive is positive. Now let's do the same thing for the acceleration. I know this is a pain, but we're going to get the job done now. Acceleration is a little bit easier because notice that the acceleration, you can write it, here it is. Where's the acceleration? Here it is. So this is the acceleration, which can be written like this. 12 times t minus 2. So essentially, we just have t minus 2 to worry about because 12 is always positive. So acceleration, when you have a number that's less than 2, which anything between 0 and 1 is less than 2, it's going to give you a negative number. When you plug that, like put a number like, like 1 into this, and that's negative, and that's the only thing that's going to change. So positive times negative makes this negative. So this is a little bit quicker. That's negative. This will be positive and positive. And so in terms of speeding up and slowing down, I guess I'm just going to write my answer down here. We're going to do this. Speeding up is where these things are the same. So that's going to be between 1 and 2, and between t is greater than 3. And the reason for this is because you're speeding up when you're going the same direction as your acceleration. So your acceleration is actually moving you forward. whichever direction is. Slowing down, on the other hand, is the other times. This will be 0 to 1, and from 2 to 3. And you can see that this is when the sign that you're going, your velocity is different direction from your acceleration. All right, this next question is not something that was on Infinity, but it might be helpful to see how things work. And so I thought I'd leave it on here. It's something that I've done in the past. And I'm just going to graph or sketch a path for this object between 0 and 4. It might help you understand what's going on here. So starting at 0, when t equals 0, so I'm just going to copy this function down here. This is s of t is 2t cubed minus 12t squared plus 18t minus 3. Okay, so at t equals 0, right there, s of 0 is equal to negative 3. So that's why the little dot is above negative 3. What's going to happen is that the dot is going to move over until it comes to rest. When does it come to rest? It comes to rest at t equals 1 and at t equals 3. So I want to know what happens at t equals 1. Excuse me. So let's compute the position at t equals 1. Oh, we did that already. It's up here in part A. So at t equals 1, the position is 5. So we're going to move over here until you get to t equals 5. S equals 5. That's t equals 1. Whoops. T equals 1. S of 1 is equal to 5. Then it's going to turn around, and the way I'm going to represent this is I'll just have it loop back around. You're still on, technically we would be starting here and then moving this way and then turning around and going back. So you start, you move, and then you keep going, and then you get here, and then you go back the other way. But let's actually just do this. So we go from t equals 1 to t equals 3. So at t equals 3, we will turn around again. So let's just figure out what s of 3 is. So let's see, s of 3 is equal to 2 times 3 cubed is 27, minus 12 times 9, plus 18 times 3 minus 3. Okay, so 2 times that's 54. 12 times 9 is 108. 18 times 3, is that also 54? Yes, minus 3. Oh, interesting. So that all equals negative 3. So I guess I'm back here. So that happens to be s of 3 is also negative 3. So what's happened is this thing has looped around. Let's see, can I? Oh, I've just erased the whole thing. Okay, so we're going this way. I'll put an arrow here in a minute. And then it turns around, goes back this way. Then it's going to turn around again. Okay, so we're going this way. And then we turn around at t equals 1, turn around again at t equals 3, and presumably keep going, but let's find out where we are at t equals 4. So s of 4 is 2 times 4 cubed minus 12 times 4 squared plus 18 times 4, and I've run out of room. Whoops, that was not right. Let's undo that. Darn it, I'm really close to the edge, so I'm having trouble grabbing. There we go. And then minus 3. Okay, so s of 4, 2 times that's 128. 12 times 16. 120 plus 72, which is 192. 18 times 4 is 32 and 40, so 72. Okay. Okay, so let's see, 120, that's 8, 8, 5. Interesting. We go out to 5. Oh, we're back to where we were just a minute ago. Interesting. So this is t equals 4. And of course, if we kept going, this thing would keep going off to the right because it never will stop. It will never turn around because it will never be at rest. Okay, so now how far is the object traveling from t equals 0.5 to t equals 4? I chose 0.5 here just so that I could illustrate that we're not just going to be computing this at integer points, but the problem is that s of 0.5 is kind of a pain. I'd actually have to do this way. This is going to be 2 times 0.5 cubed minus 12 times 0.5 squared plus 18 times 0.5 minus 3. I did this earlier on my calculator, and I got negative 1.25. Hopefully I got that right. That doesn't look right. Let me do it again on my calculator. Sorry, I'm looking at it. It doesn't look right. Okay, so 2 times 0.5 cubed minus 12 times 0.5 squared plus 18 times 0.5 minus 3. 3.25, yeah, I didn't think it looked right. Let's try it there. So I just did this on my calculator, which I know you can't use on a test, but don't worry, I'm not going to do something like this on a test. But I'm at 3.25. So starting here at t equals 0, here's what's happening is you're starting right there, and then you move to right here. And that's where you are at t equals 0.5. So let me just put that right here. So here's t equals 0.5. And I want to know how far the distance, how far do we actually travel? So notice where we're going. We're starting here, that's t equals 0.5. You go over to here, which is a little bit. Then you go clear back to there, which is a total distance of, what, 8? And then you go clear back to here, which is another 8. So maybe I'll just write this down here just to emphasize this, that you go from t equals 0.5 to t equals 1, and then you're going to go t equals 1 to t equals 3, and then t equals 3 to t equals 4. And here we go. So this is the distance. Okay, so the distance traveled from, let's see, this is 3.25 to 5, so that's going to be 5 minus 3.25, 1.75. The distance from t equals 1 to t equals 3 is 8, because you start at positive 5, you end at negative 3, so that's 8. And the same is true from 3 to 4. Now let's get the total. 8 plus 8 plus 1.75 is 17.75 units, whatever they are. There it is. Hope that helps. Don't forget to like and subscribe.